Hi, my name is Amina and we will look at the random variables. The word random effectively means unpredictable. In engineering practice, we may call some signal as random to simplify the analysis even though they may not actually be a random. A random variable is a function that assigns the outcome of an experiment, that is a sample space, onto the real line, and we can define arbitrary number of random variables that are of interest. Let us look at the classical example of tossing a fair coin. Suppose we toss a fair coin 3 times and S is the sample space of tossing a coin 3 times. And here H represents the head and the T represents the tail. And now if suppose we flip the coin 4 times or n times, then instead of considering all the possible outcomes, let us consider defining a random variable x. Suppose we flip a coin 3 times and we consider x as a random variable, that is a number of heads in the 3 flip of a fair coin. Then x can take values 0, 1, 2 and 3. So here 0 means there will be no head. 1 means there will be one head in occurrence of in the tossing of 3 coins, and 2 means there will be 2 heads, and 3 means there will be 3 heads in 3 toss of a coin. So here we can choose x also as a number of tails in and flip of a fair coin, so that will be of our interest. Here the random variable x, capital X is for the random variable and small x is a numerical value it takes. And we will look some theorems on random variable, that if x1 and x2 are random variable and c1 and c2 are some constants, then x1 c1 x1 minus x2 or c1 x1 plus c2 x2 x1 x2 or c2 x2, these all are random variables. Also, mean of x1 x2 and max of x1 and x2 are also the random variables. So if x is a random variable, then 1 by x, a mod of x are also random variables. If x is a random variable and suppose g is some continuous function, then g of x is also a random variable. Next, the probability of a random variable x taking the value less than or equal to some given value. So the probability of random variable x taking some value being less than or equal to some value x is defined by the distribution function, that is capital F of x, or simply you can call it f of x, is a probability x, the random variable taking value less than equal to x, and where x belongs to any real value. So the properties of distribution: if x is a random variable having a distribution function f of x, then the probability of the random variable x lying between a and b can be calculated as f of b, means the distribution function at b minus distribution function at a. And the distribution function of the random variable x lies between 0 and 1. And the distribution at x is less than equal to distribution at y, that if x is less than y. This means f of x is increasing function. Suppose this is a positive real line, and this is x and this is point y, then the distribution function at x is less than the distribution function at y. Then further the distribution function at infinity, that is limit x approaching to infinite, f of x is equal to 1, that the distribution function can take maximum value 1 and the minimum value, that is at minus infinity, it will be 0. Next we will look on the other aspects of the random variable.